Simplifying trig expressions and proving trig identities. To be able to do this, we first need our tools. Those tools include the fundamental trigonometric identities, and of those we have reciprocal identities. Sine of u equals 1 over cosecant of u. That means cosecant of u is 1 over the sine of u. Cosine of u is 1 over the secant of u. Secant of u is 1 over cosine of u. Tangent of u is 1 over cotangent of u, and cotangent is 1 over tangent. And then we have the quotient identities. Tangent is sine over cosine. Cotangent is cosine over sine. The Pythagorean identities. Sine squared of u plus cosine squared of u equals 1. Tangent squared of u plus 1 equals secant squared of u. And 1 plus cotangent squared of u equals cosecant squared of u. The cofunction identities, which is basically talking about if we have them in a right triangle, if I have the sine of 90 minus u, that'll equal the cosine of u. If I have the cosine of 90 minus u, that'll equal the sine of u. But these are both written with the 90 degrees in radians, which is pi over 2. Tangent of 90 minus u is cotangent. Cotangent of 90 minus u is tangent of u. Secant of 90 minus u is cosecant of u, and cosecant of 90 minus u is secant of u. And the even and odd identities, sine is an odd function, so the sine of negative u is negative sine of u. Cosine is even, so the cosine of negative u is cosine of u. Since tangent includes sine and cosine, it's odd. Tangent of negative u equals negative tangent of u. And then cosecant is odd because sine is odd, so cosecant of negative u equals negative cosecant of u. And secant is even because cosine is even, so secant of negative u equals secant of u. And cotangent is odd because tangent is odd, so cotangent of negative u equals negative cotangent of u. Some basics: combine any like terms, factor, get everything in terms of sine and cosine, cancel common factors, multiply by the conjugate are all tools that we can work with. Now, one of the things I have to say is there are more than one way to work through these, so you have to show your steps. That proves your answer logically. So first one, sine squared of x times secant of x minus secant of x. Well, we can simplify that by factoring out secant of x. Sine squared of x minus 1 kind of looks like sine squared plus cosine squared equals 1, but I have to pull out a negative 1 to make that work. Because then 1 minus sine squared is cosine. Secant is 1 over cosine, so now I can cancel a cosine, and that simplifies just to negative cosine of x. Now on B, please correct it. It should read cotangent squared of x minus 2 cosecant of x minus 7. Pause the video if you need to write that correct one. Okay, now take a look. Cotangent squared of x, that is a Pythagorean identity. We can replace that with cosecant squared x minus 1 minus 2 cosecant of x minus 7. Simplify, that gives us cosecant squared of x minus 2 cosecant of x minus 8. Now that looks like a trinomial. Something squared minus 2 times that something minus 8, so factor it. Cosecant's got to go up front in each, and then factors of negative 8 that add up to negative 2. Well, 4 and 2 multiply to get 8. A negative 4 plus a positive 2 would get us negative 2. And so cosecant of x minus 4 times cosecant of x plus 2 would be what it simplifies to, or factors to, I should say. Next one, on C, we can pull out a secant, and then cosecant's 1 over sine. Make that one fraction inside the parentheses, so that means sine of t on that right-hand side is over 1, so I have to take its top and bottom times sine of t. That gets us 1 minus sine squared of t, and secant of t is 1 over cosine. And then 1 minus sine squared is cosine squared. Now I can cancel a cosine, top and bottom. So I have cosine over sine, which means that is cotangent. The next one, rewrite sine squared of y over 1 plus cosine of y, so that's not in fractional form. So we start with multiply by the denominator's conjugate. So multiply top and bottom by 1 minus cosine of t. Leave the top factored out. The bottom multiplies to 1 minus cosine squared of t, which is the same as sine squared of t. The sine squareds cancel, and we're left with 1 minus cosine of t. That's one way. The other way, we could just take that sine squared of t on top, and that can be rewritten with a Pythagorean identity as 1 minus cosine squared of t. That factors into 1 plus cosine of t times 1 minus cosine of t. The 1 plus cosine of t cancels top and bottom, and again we are left with 1 minus cosine of t. So there were two ways to work this problem. Both are logically correct. So how do you know which one to use? It doesn't matter. As long as you show your work, that is the key to getting these types of answers correct. Use the substitution x equals 5 sine of theta, and theta happens to be in the first quadrant, to write the square root of 25 minus x squared as a trigonometric function of theta. So x is 5 sine theta, so we can simplify that into square root of 25 minus 5 times the sine of theta squared, which gets us square root of 25 minus 25 sine squared of theta. Factor out a 25. That gives us 1 minus sine squared of theta, which is the same as cosine squared of theta. And now the square root of 25 is 5. The square root of cosine squared is cosine. So 5 cosine of theta. You've got some practice for simplifying trig expressions. Go ahead and try those. You can go ahead and pause the video and then start it up again once you've done those 6. Continuing on, reminding us of our identities that we'll be working with, and now we're going to prove some trig identities. Guidelines for verifying trigonometric identities. Work with one side of the equation at a time. It is often better to work with the more complicated side first. Look for opportunities to factor an expression, add fractions, square a binomial, or create a monomial denominator. Look for opportunities to use the fundamental identities. Note which functions are in the final expression you want. Sines and cosines pair up well, as do secants and tangents, and cosecants and cotangents. Those we're talking about because of the Pythagorean identities. When the preceding guidelines do not help, try converting all sides to sine and cosines. Always try something. Even making an attempt that leads to a dead end can provide insight into the problem. So here we have a couple identities. Cosine of squared x equals cosecant squared x minus cotangent squared x over tangent squared x cosecant squared of x. Which side's more complicated? The right-hand side. So start with it. Notice how I've labeled this right-hand side. And I've just taken the top cosecant squared x and used a Pythagorean identity. That's equal to 1 plus cotangent squared of x. I can simplify that to just 1 on top. And tangent squared and cosecant squared I turned into sine and cosine. And notice what cancels. The sine squareds will cancel on the bottom. So I have 1 over the cosecant squared of x. The reciprocal of the denominator is basically what I'm looking at. So that would end up being just cosecant squared. Now on B, taking a look at that, the left-hand side looks more complex, so I'm going to start with it. And if you notice, the first thing I did is I tried to make it into one fraction. And so I took the first fraction top and bottom by secant of y plus 1. I took the second fraction top and bottom by secant of y minus 1. When I multiply those on the bottom, that's a difference of squares, so that's why we got secant of squared x minus 1 on the bottom. On the top, that's going to simplify to 2 secant of y, and the 1's cancel, and then secant squared of x minus 1 is tangent squared. Reciprocal of tangent squared is cotangent squared of y, and then we've got secant of y. That I can rewrite as 2 over cosine squared of y over sine squared y times cosine. I can cancel a cosine. That gets us 2 times cosine of y over sine squared of y. We can write that as cosine over sine and 1 over sine. So that gets us cotangent of y times cosecant of y. And we would be done. Looking at C, it looks like the left-hand side's a little bit more complex. Cosecant squared theta minus 1 can be written as just cotangent squared of theta. Cosine squared theta minus 1, I can pull out a -1 and change the signs on each thing. And then 1 minus cosine squared is sine squared. Cotangent squared is cosine squared over sine squared. The sine squareds cancel, and we're left with -1 cosine squared of theta, which is our right-hand side, and we're done. Now on D, it looks like the right-hand side is a little bit more complex. So I started by multiplying top and bottom by the denominator's conjugate. That makes the bottom 1. And then cotangent is cotangent's cosine over sine, secant's 1 over cosine, and tangent's sine over cosine. So on the first one, the cosines cancel. On the second one, everything cancels. So we have 1 over sine theta plus 1, and 1 over sine beta is cosecant, and we are done. Looks like the left-hand side. Example E looks like the left-hand side is a little bit more complicated, so we can start by rewriting tangent squared of theta as secant squared theta minus 1. That factors into secant theta minus 1 times secant theta plus 1. The secant theta minus 1's cancel. Secant theta is 1 over cosine of theta. Multiply through by the sine of theta, and we end up with the tangent of theta plus sine of theta. That doesn't look like the right-hand side. So let's see if we can make the right-hand side look like this now. So starting with the right-hand side, cosine theta plus 1, and cotangent on the denominator is the same as cosine of theta over sine theta. Multiply by the reciprocal, so cosine theta plus 1 times sine theta over cosine theta. Distribute that on cosine theta times that fraction. The cosine thetas will cancel. We'll get sine theta. 1 times sine theta over cosine theta is just tangent theta. And now left-hand side looks like right-hand side, and we would be good. So now you've got the verifying trig identities practice, as well as the simplify that you had before. Make sure you check those with me. You probably want to put these on another piece of paper so that you can follow the logic through. Make sure you are labeling left-hand side, right-hand side, whichever one you are starting with. Thank you.